Alright, this video is the third in a series about creating a physics engine. It's about the simplest physics engine I could conceive of. We're only modeling sort of two physical properties, the velocity of a circle moving across the screen and the position of that circle. We are also about to add some effects that will make the circles bounce off the edges of our canvas. Okay, so what are we trying to build? Let's just run that one more time. This is the final version of what we would like to get to. So we have, again, these circles on the screen, and they have a velocity. That velocity dictates their position. And so every single time we animate, every frame of our animation, we have to lay down a black background and then draw our circles. And then the next time through the loop, we have to update the positions. So all of these circles have a velocity, so we have to update their positions based on their velocities, right? And then we will have to draw the black background and then all the circles in their new positions. And then at some point we're going to have to look into collisions. So when the X position goes outside the maximum X, I'm sorry, that's the Y position. So if the Y position goes outside the boundary of the maximum Y, we need to reverse the velocity in the Y direction. And if in the X direction it goes beyond the boundary, we need to reverse the X velocity. All right, so let's get started on that. Where we left off is part 2, and here's what we have so far. Okay, so one of the nice things about this is last time we abstracted away the idea of relying on the speed of the computer or the performance of the machine to dictate how fast the animation goes. So what we did is we started using time, which that's more natural. That's actually more physics-based, right? You calculate the distance the distance things travel using the velocity times time, right? So each time through this loop we get an interval. It's the difference between now, which is the current time. That's the number of seconds since 1970. So now, and then we subtract the last time we calculated now, which would be the last time through this loop. So this interval is the interval of time between loop iterations. And then we can use that interval to calculate the new positions of all of our circles. So in this case, we only have one circle, and we're sort of defining all of those properties of this circle in the global scope of our program. So if we want hundreds of these, we could obviously just add a number at the end or at the beginning of each one of these, but that would clutter up our global variable scope. We'd have variables everywhere. All right, so what we need to do is probably find a better way of storing information about one particular circle, because we're going to have lots of those circles. So we mentioned last time the proper way to do this would probably be with a class, but some people might not have experience with making classes in Python, and I want to keep this accessible. So we're going to use a dictionary to store these values. So that's sort of the first thing we need to do in this part 3. Okay, so again, we left off at part 2. Once you get to a reasonable stopping place, it's a good idea to copy your file, duplicate this file, and that way you can always revert back to a previous state. Okay, and there are better ways of doing this than just copying the files, but in a pinch, just copy the file and then you have a backup of where you were. So this is sort of the most basic type of version control you can have when you're coding up something. So this is like our version 3. Each time we iterate to a new version, we have more functionality than we did before, and we can always revert back to a previous version. So again, there's whole branches of computer science surrounding version control, but this is the easiest way you can implement your own version control on your programs, especially simple little programs like this. Okay, so let's abstract away this idea of a specific circle, right? We want to abstract this concept away and have hundreds of different circles. Okay, so we're going to have to store circle data in dictionary. All right, so and so what this is going to allow us to do is we're going to make a function that's going to draw all of the circles, right? And then basically this will all get cleaned up. We'll have a function that will update all the positions, we'll draw the background, and then we'll draw the actors. And so this main window, or this main animation loop, is going to get cleaned up and look it will be easier to read what's going on. Right now we can tell what's going on, sort of by the comments, and if you follow the code, you can read what's going on, but it seems a little bit cluttered, so it'd be nice to clean that up. So that's another thing we're going to do. Keeping your code clean and organized is extremely important for readability, not just for yourself, but for anybody else you might be working with, right? Okay, so let's start by defining a function that might be something like create circle. Okay, so the idea here is we're going to create a circle, and what do I mean by a circle? Well, I just mean a data structure that's going to store all the properties we need to model the physics of one of these circles. So the physical properties we need at this moment are an x, a y, and a vx and a vy. So that's velocity in the x direction and velocity in the y direction. And real quick, just to go over what we did last time, if you're not familiar with vectors, you might watch a video on that, but the basic idea is a vector in any direction in the two-dimensional plane can be broken down into components. So this resultant vector, this green vector here, this would be, in terms of velocity, this would be 5 meters per second. We can break that up into components, and we can say that is 3 meters per second in the x direction and 4 meters per second in the y direction, right? And so this is a right triangle, so using the Pythagorean theorem, we can say a squared plus b squared equals c squared, so that would be 3 squared plus 4 squared, so that's 25, and c squared is 25, right? So you can use that to calculate this resultant vector whenever you want. But this is basically just showing that's why we are keeping track of the idea of the velocity in the x direction and the velocity in the y direction, because with those two variables you are essentially just talking about any vector in any direction, right? So we can use those two variables, and we're keeping track of a vector in any direction, which is important because we're in two-dimensional space and the circles can be moving in any direction. All right, I'll close that window and close that one too. All right, so we want to create one of these circles. So what information? So I'm going to start with a dictionary. And so this dictionary is going to contain properties. It's going to have an x property. And what do I want to start this this dictionary? What do I want to start its properties out as? Right? I think we could just do random data. Right? So at the top here, from previous, like from the very beginning, we've imported this random module, and we haven't really used it yet. So for the sake of this particular demo, we want the circles to just kind of show up in some random position, right? So what are the allowed positions for our x value, right? So this would be called the random package dot rand int, and so the beginning, the maximum and minimum values that we allow, right? So what are the maximum and minimum values we allow? So we would say minimum value x. So these are where these constants that we defined at the beginning are going to be coming in useful, right? So the minimum value of x, right, and then the maximum value of x, right? So that seems reasonable. All right, so we can do that. We will say we need, what else do we need for a circle? We need the y. So that y position, we're going to get a random number. And this is going to be from the minimum value of y to the maximum value of y. Okay, then we need, what else do we need for a circle? We need a radius. All right, so the radius of the circle, random.rand int, and we can make this whatever we want. We could make these bigger or smaller than the ones I had in the other demo. So if we wanted some that were smaller, we could say this could go from 5 to 50, or even smaller than that if you want. 50 is pretty big, so there'll be some large circles in there, maybe 5 to 40, right? So notice this, we're creating a dictionary here, and if you're not familiar with that, a dictionary is just a collection of variables, kind of like a list. The only difference is with lists, you reference by index to retrieve a value or set a value. Here, you reference by key, right? And the key in our cases is always going to be a string. In most cases with dictionaries, it's always a string. Python allows for other types of keys, but just to keep things simple, always just think about a dictionary as a key and a value. Right, so here the key is x, so this is the x property of one circle. This is, the y property of one circle. Okay, and for each one of these key value pairs, we have a comma afterwards, right? So it's the key as a string, colon, then the value, and then comma, right? So we're doing that for all of these. Hopefully you're familiar with dictionaries. All right, so what else do we need for a circle? We need the velocity in the x direction. And we can say that's random. So how fast do we want, want these to go, right? So we want random dot rand_int, and we could say this is going to be in pixels per second, right? So we could start anywhere from maybe -100 to +100 in the x direction, and then we could have, I just duplicated that line, velocity in the y direction, and that's the same thing. Okay, so it is possible here that we might get 0 and 0, in which case we just have a circle, like for these two values, this would be a 0 and this would be a 0, and that would just be a circle that isn't moving. Or we could get very low values here. So some of the circles you might see are just going extraordinarily slow, while others are going, 100 in the x direction, 100 in the y direction. All right, so let's take a look at this. Let's see, what else do we need? We might have a color also for these circles, right? So each circle is going to have its own color. How can we make a color? Well, we can make 3 random integers. So the red color would be random rand_int from 0 to 255. The amount of green would be the same, and then the amount of blue would be the same. Okay, so red, green, and blue, I'm getting a random value from 0 to 255. So this is where, up at the top, we have turtle color mode, 255. This allows us to specify a tuple of red, green, and blue colors from 0 to 255. So a tuple is just like a list, except it's immutable. You cannot change the values once you create a tuple. So with the list, you would use square brackets, and we put red, green, and blue in here. But with a tuple, you use parentheses. So red, green, and blue. And again, this is essentially, you can think of it, it's a collection just like a list, and you can access the items the same way as a list. The only difference is that you can't modify the items of a tuple once you've created it. Okay, so our color is just a tuple consisting of these 3 values from, each one is between 0 to 255. And so we can use this to determine what color we use when we draw our circle. All right, so that should at least get us started for a circle, right? Now we're going to have to modify this a little bit, but anyway, we're creating this circle, and we made this dictionary, and this is just one of our circles. So when we call create circle, we want to return the circle we created. All right, so this is the output from the create circle function. This is going to create a random circle for us. All right, and then we need a function to draw a circle. All right, so define draw circle, and this is one of our circles. This is not the turtle graphics dot circle. Okay, this means something else. When we draw a circle, we have to lift the pin up, move to an X and Y position. We have to set the heading. So drawing a circle is basically all of this stuff, right? So what we can do is sort of look back, forth, or we can copy We can copy this and paste this. So we're going to draw a circle here. What circle are we drawing? Well, that's going to be passed in as a parameter. All right, and then we can sort of use this as a reference. All right, so to draw one of these circles, we need to lift up the pen. We need to go to the circle's X position, right? So that is on this dictionary. So instead of circle X here, we say circle, right? That is the parameter we've passed in, right? So that's the variable circle. Then we access the items there using the string, so that's X, and then this is circle Y. All right, we set the heading, pen size, pen color. So pen color and fill color we're going to get from the circle object, and that's going to be this color property. We're going to use the same color for both, or we could keep pen color white, and we'll just do the fill color as red. So it's going to be color, or I'm sorry, circle, and then the key to that dictionary value is color. There we go. All right, so that's our fill color. We put the pen down, we begin the fill, and we draw our circle. Okay, so this is the radius of our circle. Now again, this is Turtle Graphics Don.Circle, right? So this is a different function than draw circle. Draw circle is drawing one of our circles that we have created. All right, so let's go circle R for radius. So up here we generated a random radius between 5 and 40. So whatever radius the circle has, we're gonna draw that. All right, and then end fill. Now it looks like one thing that we left off here is when we were drawing this. When we go to, let's see if we go to a position. So my cursor, if that's 0, 0 position, right? If I start drawing the circle, I set the heading to the east, which is over here. So here's 0, 0. The way Turtle Graphics draws the circle, that's not the center of the circle, that's the bottom, and it's going to start drawing the circle like this, right? So if we actually want our X and Y position from our circle objects to be the center of the circle, right, we want to first move down by the radius, and then it'll draw the circle around our X and Y coordinate. So here, if this X and Y is supposed to be the center of our circle, right, we want to subtract from the Y value. We want to come down, right? So we're gonna from the Y value, we're gonna subtract the radius, and then we can draw our circle around that center point. So this very first go-to is where we're putting the turtle to start with. So this is where we would need to subtract circle R. Okay. So we left that off here, but it really isn't important down here. It is going to become important that we know where all these objects are based on their X and Y coordinates when we start thinking about the collisions, which is coming up here soon. All right. So we have draw circle, create circle, and draw circle. All right. And so we want to think about updating positions. Okay, so we have a circle, and we want to update circle position. Or we can just say update circle. Excuse me. So this function is going to take in our interval. Okay, so we calculate this interval in this while loop. This is the amount of time that's passed between the last frame. So we're going to use that interval, and we're going to use the circles. We're going to need one of these circle objects as well, right? And you could decide which order you want to put these arguments in. You might have a circle first and then interval. It doesn't matter, but you are going to need these two pieces of information to update one of the circles. Okay, so we're updating the circle, we can kind of look at what we had down here. It was actually relatively simple, right? The x value, we're just going to add on to our x value whatever our velocity is times the interval. Right? Velocity times time is some amount of distance. So this is the amount of distance that's traveled by our circle over this interval of time. Right? So we're going to add that distance to whatever value we had in x already. Right? So up here, we're going to say circle x is going to equal whatever it did before plus the velocity in the x direction times this interval of time. Okay, and then the same thing for y, circle in the y direction is going to equal whatever it did before plus the velocity in the y direction times the interval. And at least at this point, that's all we do to update a circle. There's nothing really else. We might add some other stuff later, but that updates a circle. And then we already have our draw circle function, right? So what we can do down here is first we'll have to create a list of circles. Okay, and we can generate however many circles we want in here for I in range, and let's say we'll just start out with 10. We're going to make 10 circles. We will say circles.append. We're adding an item to our list, and we create a circle. Okay, so create circle is the function call up here, and this is going to return our circle dictionary. Okay, so what we're doing here is in a loop we're creating 10 circles. Create circle is going to be a dictionary, and we're adding the dictionary to the list. So this list is going to wind up being a collection of 10 different dictionaries. Each one of those dictionaries represents one circle that we're going to draw. All right, so this generates the circle. Here, I'm going to move this comment back down to the while loop. All right. So we don't need these circle values anymore because we have all these dictionaries. All right. So the circles dictionary, and then so to update all of the circles, for circle in circles, we can call update circle, and we want to pass in one of these circles and the interval. All right, so we have to pass in the circle. So this is a for loop. It's iterating over the list of circles. Circle becomes one of those dictionaries, one of those circle dictionaries each time through this loop. The first time it's the first circle dictionary, the second time it's the second one. Okay, so each time through this loop it's a different circle dictionary, and we're passing in circle and the interval. Right, so that should update our circle. Right, we keep our time calculation the same. Draw background, that can be the same. Just to clean this up a little bit, we can put this don.clear in our draw background function, just so it's a little bit cleaner. Right, so because we always have to do these both at the same time to draw the background, so just to make the code a little bit cleaner, I'm going to cut this and put it inside this function. All right, so we go up to draw background, and we're going to paste that in there. Okay, so functionally we're still doing the exact same things, right? But down here that removes an unnecessary line of code, and now we can see from the function name that this is drawing the background and we don't have the extra clutter. All right, so we're updating positions, we're drawing the circles, so now we need to draw the we're drawing the background, now we need to draw the actors, which are the circles. So for circle in circles, we basically want to do all this stuff. Well, luckily we have a function for that. Okay, so we can get rid of that. We have the function that we just created, draw circle, right? And we need to pass in a circle object. Okay, so for circle and circles, draw circle. Okay, and now just looking at our code, it's a little bit cleaner now, right? We have we don't have all the clutter from draw the actors. We're updating the positions with one function call. That's nice. We've got our time calculation here. That's nice. And then draw background is just one line of code. And then we've got sort of our cleanup, things we have to do at the end. Right? So this is cleaner. The code's cleaner, which is good. And then we've also added this abstraction away from one specific circle into some generalized concept of many, many circles, right? So that idea of abstraction comes up all the time in computer science. So we've abstracted out the ability to draw one specific circle, and now we can draw any number of different circles using this draw circle method. All right, so let's save part 3 and just see where we're at. So Python 3 part. Not bad, right? And notice, see, some of them have different velocities, right? And we can change some of this as well. We can how many circles do we want? You know, we can double it. We can go to 20. Right, and then we could see how much we want to push the system. Let's go to 50 and see what we get. And you see, as we get 50 objects, it takes longer for Python to draw, and so you see the frame rate goes down. What I mean by the frame rate going down, you can tell because the faster circles look kind of jerky. They don't look smooth. Whereas if I have just 10 circles here, we see the frame rate's going to be very, very high, and the circles are going to be traveling much more smoothly. See, that's a much smoother velocity. You can especially tell on the fast circles about what the frame rate is. We could calculate the frame rate and print it out down here if we wanted to. All right, so yeah, we can do that. We can calculate the frame rate. Yeah, let's do that next time. So we're at a good stopping point here. We've cleaned up the animation code, right? And we've also abstracted out the concept of circles. So we have something that's functioning, and it's functioning better than we had it before. Our code is better, and we have multiple actors now. All right. So sort of the last step is we need to figure out how to collide with the barriers, right? And then you've got something interesting. You could also, if you wanted to make a game like, you know, pool or something like that, you could collide with the other balls. Now those collisions are quite a bit more complicated. You'd have to get into some trigonometry. So I want to keep this video as a beginner type video. So we're not going to do any of that. But you could theoretically do it, right? So at the end of these videos, you sort of understand how modeling the physics works. Again, this is super basic. This is as basic a physics engine as you could pretty much make. And the properties of the physics engine are velocity and position, right? And then we're going to add bouncing in the next video. All right, so just scan through the code one more time. Draw a background was new, or no, we modified that. So that was an old function, but we added the don.clear there. We added this new function to create circle, and by creating circle, we're just creating a data structure to hold the properties of each one of our circles, and this creates a random circle. We have a function to draw the circle, and we had to add this part here where we subtract the radius of the circle from the beginning point. And then we added the function update circle. And then here we're creating a list of our circles. So however many numbers of circles here, what we can do is up here at the top, we can say number of circles. And we can specify this. This is a great example of a constant value in use, right? We can say we want 20 circles. That's the number of circles. So each time we run this program, we can change this before we run the program, but during the execution of this program, this is a constant variable. It's going to stay the same for the duration of one execution of the program. So here, instead of 10, we put the number of circles. Now this loop is going to run however many times we specify at the top and create that many circles. Right? Then we still have our time calculation. We update the positions, draw the background, draw the actors, or draw the circles, right? And then that updates the canvas, turtle graphics, and then we set the last now equal to now and add a little bit of sleep in there. All right, test it one more time, make sure we didn't break anything. All right, so the last thing to sort of do is the collisions, and we'll do that in the next video.